Okay, so we have looked at limits so far, but the limits that we have looked at have only been as x approaches infinity. So today we're going to look at limits that approach any value. So it could be limits as x approaches 4 or 0 or 27. And today we're just going to look at finding those limits numerically. So we're going to begin with this informal definition of a limit. I know that this probably doesn't look very informal because it's kind of long and has a lot of notation in it, but if there is a number L such that the value of f of x gets closer and closer and closer to L as x gets closer and closer to a number A, then L is called the limit of f of x as x approaches A. So to sort of break this down a little bit, we're looking at our x value. As our x value gets closer and closer and closer and closer to a given number, so that A right there could be like a 3. So as the x gets closer to 3, it might be 0, and then 1, and then 2, and then 2.5, and 2.9, 2.99, and so on. As it gets closer to that value 3, we're looking at the value of f of x. So we're seeing if the f of x or the y value gets closer and closer and closer and closer to a number. And if it does, then that is the limit, the L, that you have there. This is the notation that you'll have for that. So let's look at some more notation. In this section, we'll be looking at one-sided limits and then also limits from both sides. So whenever you see notation that looks like this, you've got the limit of f of x as x approaches A, and then you have a plus sign behind your A. The plus is not in front of the A. This is not a positive A, but the plus is behind the A. What this means right here is the limit of f of x as x approaches A from the right. Okay, so we're looking at the value of the function as x approaches A from the right side. If you have a minus sign behind your A, then that means the limit as f of x as x approaches A from the left. So this one would be the limit of f of x as x approaches A from the left. So this is your right-sided limit, and this is your left-sided limit. Now, in order for the limit as x approaches A to exist, whenever you see the limit as x approaches A without a plus or a minus behind it, that means the limit as x approaches A from both sides of f of x. In order for that limit to exist, the limit from the left and the limit from the right must be equal to each other. Okay? So let's look at some examples here. Alright, so here we have this example. We've got f of x equals x plus 3 over x squared plus 4x plus 3. And so I want to find f of negative 3. So if I'm asked to find f of negative 3, I'm just plugging negative 3 in. So f of negative 3 would be negative 3 plus 3 over negative 3 squared plus 4 times negative 3 plus 3. And so that gives me 0 over 9 minus 12 plus 3, what actually gives me 0 over 0, which this is the indeterminate form. So I don't have a value here at f of negative 3. That tells me there's a discontinuity there. If I'm finding f of negative 1, if I plug in f of negative 1, I've got negative 1 plus 3 over negative 1 squared plus 4 times negative 1 plus 3. And that's going to give me 2 over 1 plus 4. I'm sorry, that's going to be a minus 4 right there. Plus 3. And so that's going to give me 2 over 0, which is undefined. Okay, so I see that at both -3 and at -1, I've got discontinuities for this graph. So what I want us to do is to look at the limit as x approaches -3 from the left. And to do this, I'm going to use the calculator. So let me grab the calculator here. Let's see. Okay, so we'll grab the calculator right here. Okay, and we've got here. Okay, and so what we're going to do is we're going to go to y equals, and we're going to type in our equation. So our equation is x plus 3, put some parentheses around that, divided by x squared plus 4x plus 3. Okay, and once I have that in, I'm going to go to my table. And right now, my table's set to go up by 100. I really don't want this. So what I'm going to do is press second window here, and I'm going to go down here to where it says independent, and I'm going to change that to ask. And then I'm going to go back to the table. So when I do that, it looks like it broke the table. It looks like there's nothing in the table. However, what it does is it lets me ask for what the independent variable that I'm wanting is. So if you think on the number line, if you're trying to approach -3 from the left, you would start at numbers lower than -3. So on our calculator, if we just type in -4, it's going to give us our value there, so -0.3, repeating. And then if I type in -3.5, which on the number line would be just a little bit closer, because if you're thinking here that you got -4 and -3, so 3.5 is right here, I get -0.4. And if I plug in -3.1, then I get -0.4762. And so, 3.1, that's closer, that's over here. And 3.001, that's going to be even closer to -3 from the left. So if I do -3.01, I get -0.4975. And -3.001 gives me -0.4998. And -3.0001 is it says -0.5, but if you look up here, if you take your arrow and go up and then go over, you're going to see it's actually -0.49997. So it's not actually there. This limit's not actually going to reach -3, because so it looks like it actually made it here. The calculator is really rounded. It's not actually going to get to -3, because right here at -3, we know it's undefined there. So it's not going to get there, but it gets closer and closer and closer and closer to this value. So based on what we found here, it looks like, this is no guarantee, but it definitely looks like this limit as f of x approaches -3 from the left, it looks like it's -0.5 here. Oh, oops. -0.5. Okay. If we use the table for the other side, if we're approaching -3, so we're thinking on number line, here's our -4, -3, -2. If we're approaching -3 from the right-hand side, then we could start at, I'm going to go back up here and clear all these out. No, I don't think it's really going to let me. I'll just type over them. So -2 is above -3. That gives me -1. -2.5 gives me -0.6 repeating. -2.9 gives me -0.5263. negative 2.99 is going to be negative 0.5025, and then negative 2.999 is negative 3.0001, negative 2.9999. At this point also looks like it's negative 0.5. You'll see here it's not actually, it's negative 0.50000025. So it looks like this limit is also approaching negative 0.5. And since the limit from the left and the limit from the right both approach negative 0.5, this limit here from both sides, the one that does not have a plus or minus either one behind this, that approaches negative 0.5 since those two are the same. Okay, so if we look at this function, but we look at some different limits here, we're going to see something different happen here. So we're still considering the same equation, but we're looking this time at the limit as x approaches negative 1 from the left. So whenever we still have that same equation in, if we're approaching negative 1 from the left, we would start at like negative 2, which we already know is negative 1. I'm just going to put these on the calculator. We'd have negative 1.5, negative 1.1, negative 1.01, negative 1.001, negative 1.0001. So if I type all those in, I can see what's happening to the function here. I've got negative 1, negative 2, negative 10, negative 100, negative 1,000, negative 10,000. So the numbers are getting more and more and more and more and more negative. So this tells me that this is approaching negative infinity. Okay, we're not getting closer and closer and closer and closer to a number like we were on the last part. We're getting numbers that are more and more and more and more negative, which tells us that we're approaching negative infinity, or probably approaching negative infinity. If we do the same thing and approach negative 1 from the right-hand side, we could start at 0, and then we'll have 0.5, 0.9, 0.99, 999, and 0.99. And so we can see here, I'm sorry, all those should be negative. Let's do negative 0.5, negative 0.9, negative 0.99, negative 0.999, negative 0.999. And so we see sort of the same thing here happening, except for all these numbers are positive. So as the limit as x approaches negative infinity from the right, f of x approaches positive infinity. So in this case, we've got these limits, or I guess these limits don't actually exist because they're infinity, but they're not the same. We've got a negative infinity from the left and a positive infinity from the right. So whenever the question is asked, what is the limit as x approaches negative 1 of f of x, this means from both sides because there's not a plus or a minus. And so we would have to say here, does not exist. Okay. If we open up Desmos real quick and graph this, so we've got y equals x plus 3 over x to the second plus 3x plus 4x plus 3. We can see here at negative 1 we have a vertical asymptote. So if I put that vertical asymptote in there at x equals negative 1, as we approach negative 1, as we get closer and closer and closer and closer and closer to that blue line that's negative 1, our y values keep going down to negative infinity. From the right-hand side, as we approach that line at negative 1 from the right, we get closer and closer and closer to that line, and our y values go up and up and up and up and up. So we're approaching positive infinity for that in that case. So that's sort of a graphic representation of what we're seeing there. You'll also notice there at -3, it's hard to, I can't get it actually on that point. Right there, oh there it was. Right there at -3, the graph is undefined. We have a hole in the graph there. However, the limit, the value that you approach from the left and the right, still equals -3, or equals that 0.5 that we found, because you get closer and closer to 0.5. So let's do another problem. Okay. So this time we're going to use our calculator to find these, and we're not going to write down the table. Whenever you do these for your homework, you don't have to write down the table. So I'm going to go to y equals, I'm going to type in 1 minus cosine x divided by x, and I'm going to go to my table. I need to look at the limit as x approaches 0, and so I need to look at this limit from the left and from the right. So if I'm starting from the left, I'm starting with numbers lower than 0, so I would have -1, and then maybe -0.5, and then maybe -0.1, -0.1, sorry, not 1, but 0.1, -0.001, and so on. And you can see over here, you're getting these values. They look kind of like maybe they're increasing, but they've got this e -4, e -5, e -6. So this function right here is approaching 0 from the left, because these are going to be really, really small fractions with that that scientific notation. From the right, we would be looking like we could plug in 1, and then maybe 0.5, and then 0.1, 0.01, 0.001, and so on. And we see the same thing is happening here. Those that scientific notation, that decimal keeps moving further and further and further to the left, so we're getting smaller and smaller and smaller and smaller. So this, from both sides, appears to approach 0. Okay. For example 3, we're going to go to y equals, we're going to type in the natural log of x divided by x minus 1. And whenever we do that, we're going to go to the table. And this time we're looking, let's delete these out. This time we're looking as x approaches 1. So if we start with numbers below 1, that would be like 0, which actually gives us an error, because this is a natural log. We can't take natural log of 0. But we could try maybe like 0.5, and then 0.9, and 0.99, and 0.999, and 0.9999. And you can see these numbers are getting closer and closer and closer to 1 as we approach from the left. Let's check from the right as well. So from the right, we have to pick numbers larger than 1, like 2. So 2, 1.5, 1.1, 1.01, 1.001. And you can see here, these numbers are getting closer and closer and closer to 1 also. So from the left and right, this limit approaches 1. So this limit is 1. Okay. On this next one, if we go to y equals, let's type this equation in, x squared plus 6x plus 5 divided by x plus 5. And I am going to be looking at this as x approaches -5. So let me delete out the values I have in here. So from the left, values would be like -6, and -5.5, and -5.01, and -5.001. And so forth. And we can see this looks like it's getting closer and closer and closer to -4. If we approach from the right, so numbers larger than negative 5, like negative 4, negative 4, negative 4.5, negative 4.9, negative 4.99, negative 4.999. We can see we also are getting closer and closer and closer to 4. So our limit here for this one would be 4. Okay. This last example we have here, you might need to be a little careful typing in. You've got 9 minus x divided by, you need parentheses around the denominator, and you'll have square root of x. Close that parentheses, minus 3. And if we go to our table, let's delete out what we already had. We are doing the limit as x approaches 9. So from the left, we would start with lower numbers like 8. And then 8.5, 8.9, 8.99, 8.999. And you can see here, you're getting closer and closer and closer to negative 6. Right here, this is not actually negative 6, but it's really close. So from the left, we certainly appear to approach negative 6. Let's test from the right. From the right side, we need numbers bigger than 9, so maybe 10, maybe 9.5, 9.1, 9.01, and you can see the same thing is happening here. So this limit here is going to be negative 6. So this is your assignment. You do not really have to show any work for this. You just need to write the limit and put what it equals. Please use your calculator to answer all these questions.